Welcome back to Programming Fluency. This is section 7.2, Pointers to Structs. Last time, passing a struct to a function copied the whole thing. For a large struct, that is wasteful. In this video, you will pass just a pointer instead and meet a clean new operator, the arrow. Let's dive in. In the last video, you passed a struct to a function, and the function got a copy of the whole thing. For a tiny point, that is fine. But imagine a struct with a 50-character name and a dozen fields. Every call copies hundreds of bytes for nothing. Let's fix that by passing just an address. This is the plan. First, why you pass a pointer. It avoids copying big structs and it lets a function modify the original. Next, the arrow operator. P arrow x means the same as in parentheses star p dot x, but reads much more cleanly. Then passing structs by pointer. A plain pointer to modify the struct, and a const pointer when you only need to read it. After that, nested fields through a pointer. You mix arrow and dot as you dig deeper into the data. Finally, structs on the heap. You malloc a struct that outlives its function, then free it when done. Let's start with the cost. Passing a struct by value copies every byte on every call. Look at the two headers. The first takes a struct student by value. That copies about 62 bytes each call. The second takes a pointer to a struct student, copying only 8 bytes, one address, no matter how big the struct. You already solved this problem for plain ints in the last chapter. When copying was wasteful, you passed a pointer. The same idea works for structs. And there is a second reason. A pointer lets the function reach back and modify the original struct, not just a private copy. Now the new operator. When you have a pointer to a struct, you can reach a field by first dereferencing, then using the dot. That is, in parentheses, star pp dot exit works, but it is clunky. Every access needs parentheses and a star. C gives you a cleaner shorthand, the arrow. You write pp arrow x, a dash and a greater than sign. Both lines print 3, because they mean exactly the same thing. Now the definition. The arrow operator accesses a field through a pointer to a struct. PTR arrow field is exactly, in parentheses, star PTR dot field. Go to the struct the pointer points at, then take the field, all in one step. So how do you know which to use? The rule is simple. Look at what is on the left of the operator. If the left side is a struct value, use the dot, p.x. If the left side is a pointer to a struct, use the arrow, pp arrow x. That is the whole rule, and if you slip up, the compiler will catch it. Let's use a pointer to modify a struct. Scale point takes a pointer to a struct point called p and an int factor. Inside, it writes p arrow x times equals factor, and p arrow y times equals factor. That multiplies both coordinates in place. In main, we make a point pt holding 3, 4. Then we call scale point, passing the address of pt with the ampersand and the factor 2. After the call, pt holds 6, 8. The change stuck because we passed the real address, not a copy. Let's trace the change step by step. Before the call, pt holds 3 and 4. When we call scale point, the pointer p is aimed at pt. It does not copy pt, it points to it. Then p arrow x times equals 2 writes directly into pt, so pt dot x becomes 6. Next, p arrow y times equals 2 writes into pt again, so pt dot y becomes 8. And here is the key row. After the function returns, pt stays changed. It holds 6 and 8 because Every write went straight into the original through the pointer. Sometimes a function only needs to read a struct, not change it. In that case, pass a const pointer. You still avoid the copy, and you promise not to modify the caller's struct. Print student takes const struct student star s and only reads the fields. If you accidentally wrote s arrow GPA equals 4.0, the compiler would reject it because s is const. So the two forms send a clear message. No const means the function may modify the struct. Const means it only reads, and a stray write will not even compile. Use const whenever a function is not supposed to change the struct. What if a pointer leads to a struct that itself contains another struct? Then you mix arrow and dot. The figure shows the expression e-arrow hire date dot year. The arrow follows the pointer into the employee, then the dot selects a field of the embedded date. First e-arrow, using the arrow, because e is a pointer to an employee. That gives you the hire date field, which is an embedded struct date, not a pointer. So to reach year, you use a plain dot. Dot year. The rule never changes. Arrow when the left side is a pointer, dot when it is a struct value. You just chain them as you dig deeper. So far, every struct has been a local variable on the stack, gone when the function returns. Sometimes you need a struct that outlives its function. For that, you allocate it on the heap with malloc. Malloc, size of struct student, asks for exactly enough bytes for one student and returns a pointer to that heap memory. Malloc can fail if the system is out of memory and then it returns null. So you must always check if s equals null before using it. Once the pointer is valid, you fill the fields with the arrow operator. strcpy for the name, then s arrow id and s arrow GPA. When you are done, you call free of s to give the memory back. This is the main reason to use the heap. A function cannot return a pointer to its own local struct. That local lives on the stack, and it vanishes when the function returns, leaving a dangling pointer. But a function can return a pointer to heap memory because the heap block survives the return. Create student allocates a student on the heap, checks for null, fills in the name, id, and GPA, and returns the pointer s. That pointer stays valid after the function returns. The caller receives it, uses the student as long as it needs, and then calls free when done. Forget the free and the memory is never returned. That is a memory leak. Allocate use free. Always finish the pattern. Now two quick bugs, and they are the flip side of each other. First, using the dot on a pointer. You have s, a pointer to a student, and you write s.name. The compiler complains, request for member name in something not a structure. Why? Because s is a pointer and address, not a struct value. The dot only works on struct values. The fix is the arrow, s arrow name. Whenever you have a pointer, reach for the arrow. The second bug is the opposite mistake, using the arrow on a struct value. Here Alice is a plain struct, not a pointer. You write Alice arrow name, and the compiler rejects it. Invalid type argument of arrow. Why? Because the arrow tries to dereference a pointer first, and Alice is not a pointer. There is nothing to dereference. The fix is the dot. Alice.name. So remember the pair. Dot for a struct value, arrow for a pointer to a struct. Let's recap. Pass structs by pointer for two reasons: to avoid copying a large struct and to let a function modify the caller's original. The arrow operator accesses a field through a pointer. P arrow x is the same as star p dot x. The rule for choosing is simple. Dot for a struct value, arrow for a pointer to a struct. A plain pointer lets a function change the caller's struct. A const pointer only reads it and blocks accidental writes at compile time. For nested fields reach through a pointer, chain the operators. E-arrow higher date dot year. And use malloc when a struct must outlive its function. Always check for null and always free when you are done. Next, typedef lets you write just student, enum names your integer constants, and union stores one of several shapes in the same memory.